Now, this question is basically of magnetism and it came in 2010. And in fact, if you basically, this question was given in the Design Tutorials booklet even prior to the paper, prior to the examination had held. Like Design Tutorials booklets, the question was there in 2009. So the students who have already done Design Tutorials booklets would have been easily solved this question in 2010. Now let us see what the question says. Two long parallel wires are at a distance 2D apart. Right, they're at a distance 2D apart and they carry steady equal currents flowing out of the plane of the paper as shown. Now these are the two wires. One wire is this and one wire is this. Right, this is one and this is the second wire. Now they carry currents. They are coming out of the paper, out of the plane. Right. Now the variation of the magnetic field along the line x dash is given by. This is the line. So how will we calculate this? Now magnetic field in between. Right. This will be given by what? Mu naught I by 2 pi x. If x is the distance from, let us suppose, one of the wire, then there will be 2d minus x, right? So the magnetic field will be this will be upwards we taken as positive, right? So beta will be plus this minus of, this is basically j cap along this direction, minus of mu naught I upon 2 pi into 2d minus x j cap, right? This will be the general equation, and because due to this wire it will be in the downward direction, so this will be negative, right? So if I see over here, whenever we are getting close to this wire, this magnetic field becomes in the downward direction, because when I am getting close, that means this distance is less and this distance is more, right? So that means it will be negative. Eventually it will be negative because all the rest of the terms are equal, right? This will be negative. So that means we can definitely eliminate option A, because over here it is saying, right, so this is basically in between. I'm sorry, this cannot be eliminated. This can be one of the correct options. So basically this will be negative because this magnetic field is when they are in between. So if I'm getting close, this will be negative, and if I'm getting close to this one first, it will be positive because this will now be less and this will be more. So eventually this term will be greater as compared to this, so it will be positive, right? So that means we can definitely eliminate option B, because over here it is saying it should be positive, which is wrong. And we can easily eliminate option C also, because over here when I'm getting close to the first wire, it should be positive magnetic field, but it is saying it is negative. So we're left with only two options, A and D, right? Now the difference over here is that it is saying while going towards the right, this is positive, right? Magnetic field is positive. So if I say towards the right, what will be the equation? The equation will be equal to mu naught I by 2 pi x into j cap. This will be positive due to this wire, plus of mu naught I by 2 pi into 2d plus x into j cap. Both of them will be increasing the magnetic field, right? It will be positive. And if I talk about over here, it will be minus mu naught I by 2 pi x into j cap minus mu naught I upon 2 pi into 2d minus x into j cap, 2d plus x into j cap, right? So both of them will be negative over here because it will be in the downward direction due to both the wires, right? So that means option A is correct. Option D is incorrect because it is showing positive over here, rather it should be negative, and it is showing negative over here, rather it should be positive, right? So that means option D is also wrong. So that means option A is the correct answer.